smartphones, and the rising carbon cost of flagship tech. As smartphone makers roll out their 2026 flagship devices, environmental impact is becoming a bigger factor alongside performance upgrades and design changes. New lifecycle analysis from carbon accounting platform Greenly examines emissions tied to several major devices, including Apple's iPhone 17 Pro, Samsung's Galaxy S25, Google's Pixel 10, and Xiaomi's 14 series. The results suggest progress is happening, but slowly. While some manufacturers are lowering per-device emissions, broader factors such as manufacturing processes, electricity assumptions, and total shipment volumes continue to define the overall footprint of the smartphone industry. Manufacturing remains the biggest source of emissions. Across the devices analyzed, most emissions occur before a phone is even switched on. Production, logistics, and end-of-life processing account for roughly 80 to 85% of a smartphone's lifecycle footprint. Among the models studied, Samsung's Galaxy S25 recorded the lowest manufacturing emissions at about 94.13 pounds of CO2 equivalent. Xiaomi's 14 series followed at roughly 104.05 pounds, while Apple's iPhone 17 Pro came in at about 112.87 pounds. Google's Pixel 10 registered the highest estimate in the group at approximately 162.70 pounds. Direct comparisons are complicated by the way companies publish their data. Apple provides emissions estimates for multiple storage configurations, noting that additional storage increases manufacturing impact due to extra memory components. Google's published figure reflects the 128GB version of the Pixel 10, while Xiaomi reports emissions for a 250GB model. Samsung's disclosures do not include storage-specific breakdowns. These methodological differences make one-to-one comparisons difficult. Energy assumptions and scale shape the industry footprint. Although production accounts for the majority of emissions, electricity used during a device's lifespan still contributes to its total footprint. Over a typical 3-year period, charging-related emissions vary depending on assumptions about the electricity grid. In the analysis, Samsung's Galaxy S25 recorded the lowest use phase emissions at just under 6.61 pounds of CO2 equivalent over 3 years. Xiaomi's device reached around 12.78 pounds, while Google's Pixel 10 was estimated at roughly 18.07 pounds. Apple's figures varied by model, with the iPhone 17 Pro at about 28.21 pounds and the thinner iPhone Air closer to 20.61 pounds. These differences are largely tied to the electricity mix assumed in lifecycle models. Charging a smartphone that consumes about 21 kilowatt-hours over 3 years could generate roughly 19.84 pounds of CO2 under the U.S. electricity mix, which still includes significant fossil fuel generation. In France, where low-carbon electricity dominates, the same consumption could result in emissions closer to 3.74 pounds. Sales volume ultimately amplifies the industry's environmental impact. Apple and Samsung together ship hundreds of millions of devices annually. In 2024, Apple shipped about 231.8 million smartphones, with Samsung close behind at roughly 223.4 million units. Xiaomi delivered around 169 million devices, while Google's Pixel lineup accounted for roughly 14 million shipments. When lifecycle emissions are scaled to these volumes, aggregate impacts grow quickly. Apple's flagship shipments alone could represent roughly 14.8 million tons of CO2 equivalent, compared with about 10.2 million tons tied to Samsung's flagship devices and close to 9 million tons for Xiaomi. Google's total footprint remains smaller, about 1.5 million tons, primarily because of lower sales volumes rather than lower per-device emissions. Even the relatively small emissions associated with charging accumulate globally. Apple's use phase emissions could reach roughly 2.6 million tons annually, while Samsung's would be closer to 660,000 tons. Some design changes may offer incremental improvements. Apple's iPhone Air, for example, introduces higher shares of recycled materials and relies on renewable electricity for around 45% of manufacturing energy. The model is estimated to reduce emissions by roughly 7.27 pounds of CO2 equivalent, compared with the iPhone 17 Pro. Per device, that reduction is modest. At the scale of hundreds of millions of smartphones, however, small changes can translate into hundreds of thousands of tons of avoided emissions. The analysis ultimately points to a broader conclusion. Improvements in materials and manufacturing efficiency are happening, but the industry's environmental footprint remains closely tied to how often consumers replace their phones. Extending device lifespans through longer software support, repairability, and more durable design may be one of the most effective ways to limit the carbon impact of the global smartphone market.